Have you ever wondered what an autotransformer or variac is and how it works? Well, an autotransformer is a type of electrical transformer with just one winding. The term auto here signifies self in Greek, referring to the single coil operating independently, not to be confused with any automatic mechanism. Now, you might be wondering, how does this differ from a two-winding transformer? The primary difference lies in the way the primary and secondary windings of the transformer interrelate. In an autotransformer, a single winding is used both as a primary and a secondary winding, while a two-winding transformer uses two separate windings for these purposes. Imagine a winding AB with total turns N1. This is the primary winding. Now picture a tap from point C on this winding. The portion BC now becomes the secondary winding. If we apply a voltage V1 across the primary winding, the voltage per turn in this winding is V1 divided by N1. Therefore, the voltage across the secondary winding, or portion BC, would be V1 by N1 multiplied by N2, the number of turns in the secondary winding. Hence, V1 by N1 multiplied by N2 is equal to V2, or V2 by V1 is equal to N2 by N1 is equal to K. This gives us a constant K, which is the turns ratio or voltage ratio of the autotransformer. When a load is connected to the secondary terminals, a load current I2 begins to flow. The current in the secondary winding, or common winding, is then the difference between I2 and I1. Now, let's talk about copper savings in an autotransformer. The weight of copper in any winding depends upon its length and cross-sectional area. The length of the conductor in the winding is proportional to its number of turns, and the cross-sectional area varies with the rated current. So, the weight of copper in the winding is directly proportional to the product of the number of turns and the rated current of the winding. Therefore, the weight of copper in the section AC is proportional to N1 minus N2 multiplied by I1, and similarly, the weight of copper in section BC is proportional to N2 multiplied by I2 minus I1. Hence, the total weight of copper in the winding of the autotransformer is proportional to N1 minus N2 into I1 plus N2 into I2 minus I1 equal to N1 I1 minus N2, I1 plus N2, I2 minus N2, I1 equal to N1 I1 plus N2, I2 minus 2, N2 I1 equal to 2, N1 I1 minus 2, N2 I1 since N1 I1 equal to N2, I2 equal to 2 into N1 I1 minus N2 I1. In a similar way, it can be proved that the weight of copper in two-winding transformer is proportional to N1 I1 plus N2, I2 equal to 2 N1 I1 since in a transformer N1 I1 equal to N2 I2. Let's assume
WA
and WTW are the weight of copper in an autotransformer and two-winding transformer respectively. Hence,
WA
by WTW equal to 2 into N1 I1 minus N2 I1 by 2 N1 I1 N1 I1 minus N2 I1 by N1 I1 equal to 1 minus N2 I1 by N1 I1, or 1 minus N2 by N1 equal to 1 minus K.
WA
equal to WTW into 1 minus K, or
WA
equal to WTW minus K into WTW. Hence, saving of copper in autotransformer compared to two-winding transformer is WTW minus WA equal to K into WTW. Now that we've covered how autotransformers can save on copper, let's dive a bit deeper into the pros and cons of using autotransformers. Like all technologies, they come with their own set of advantages and disadvantages, which we'll discuss in detail. Firstly, the advantages. Autotransformers are smaller in size compared to two-winding transformers of the same power rating, which makes them more compact and easier to install. They also demonstrate higher efficiency, as there are fewer losses due to resistance in the windings. Moreover, autotransformers provide better voltage regulation due to a lower drop in voltage when the load is applied. However, autotransformers are not without their disadvantages. One of the major concerns is the risk of a higher voltage impression on the secondary side if the insulation between the primary and secondary windings fails. Also, they can produce severe short-circuit currents under fault conditions, which can lead to more serious damage. The changing primary and secondary phase angle can introduce complications, especially in systems where phase relationship is crucial. Moreover, maintaining the electromagnetic balance of the winding can be a challenge, which might affect the overall performance of the transformer. In conclusion, while autotransformers offer several benefits such as copper savings, improved efficiency, and better voltage regulation, they also come with their own set of challenges. It is important to carefully consider these factors when deciding whether to use an autotransformer in your application. Now that we've gone over the advantages and disadvantages of using autotransformers, let's shift gears and explore some of their applications. You might be surprised by the range of uses these compact and efficient devices have. Firstly, autotransformers are often employed to compensate for voltage drops by boosting the supply voltage in distribution systems. This helps maintain a steady and reliable power supply, even under heavy load conditions. Secondly, autotransformers equipped with a number of tappings are commonly used for starting induction and synchronous motors. By gradually increasing the voltage, these transformers enable a smooth and safe startup of these motors. Lastly, in laboratory settings or in situations where a continuously variable voltage over a broad range is required, an autotransformer, also known as a variac, is the go-to choice. These are just a few examples of how autotransformers are used in various applications. As with any technology, the key is to understand its capabilities and limitations and to choose the right tool for the job. As we wind down this deep dive into the fascinating world of autotransformers, we'd like to take a moment to thank you for joining us on this journey. If you found this video informative and helpful, we'd greatly appreciate it if you could hit the like button. It helps us understand what kind of content you enjoy and want to see more of. We also encourage you to share this video with anyone you know who might find this information useful. Autotransformers are a crucial part of many electrical systems, and understanding them can be greatly beneficial. Don't forget to subscribe to our channel if you haven't already. We regularly release videos on a wide range of topics, and we'd love for you to join our community of learners and enthusiasts. Finally, if you have any questions or thoughts about autotransformers or anything else we discussed in this video, please feel free to leave a comment. We'd love to hear from you, and your engagement helps us create more informative and engaging content. Remember, your engagement helps us create more such content. So don't forget to like, share, subscribe, and comment.